Hi, this is Mr. Manley. In this video, I want to review the domain of a function. The domain of a function. And this is something that students begin learning in algebra, I believe, and then certainly build on that and learn more about it in intermediate algebra or algebra 2. Hopefully the words that you're familiar with, hopefully you're familiar with the words domain and range. And think about what you know about those words. The domain usually refers to the x value as we're learning about it and using it in mathematics. But what's more important is that it's the input. And we don't always have to have x represent an input in an equation, I hope you know by now. But for most of our purposes, the domain is x, the x values, but more generally speaking, it's the input. The range is the y values, and that's the output. So I want to talk here about the domain. I'm not going to get into the range at all, but I did want to just remind you, or I think that might ring a bell if I talk about domain and range. And that's something that you've heard before. And here specifically, I'm going to talk about domain. So the domain is the x values that are the inputs. And what we're interested in is looking at a function and seeing what inputs are allowed for x. So that's what I want to do for each of these four functions over here. This f1, f2, f3, f4. These are four different functions, and I want to talk about the domain of each one. Actually, before I talk about the domain of each of these, let's just say that there are only really, when we're talking about expressions, functions, and talking about algebraic expressions that are functions, there are only two limitations that are going to come up for just about every math student, and that is a limitation on the denominator. So the denominator cannot be equal to 0, and there's going to be a limitation on a square root, where the radicand of a square root has to be greater than or equal to 0. These are the only limitations that we're going to encounter. And then, as we'll see in my examples over here, we'll see a combination of those two limitations. So anything else, the domain, if there's no denominator and there's no radical, the domain is all real numbers. And the way we're going to represent that with what is called interval notation is that our values of x can go from negative infinity to infinity. And that is any function, if it does not have a radical or it does not have a denominator, that is the domain. The only other exception, which I'll say here, and I hope it doesn't confuse you because you probably won't see it at all, but the only other exception would be if there's some context. So if you're working with a word problem, for instance, and you have some value that it doesn't make sense unless you only use certain values within the context of the word problem. The second one here is a radical. So my domain is that the limitation on x is that x minus 3 has got to be greater than or equal to 0. I don't want to have a negative radicand. Of course, radicand, I hope you know that word. The radicand is the value that's beneath the square root or beneath the root symbol. So this is the radicand. All right, so I need my radicand to be greater than or equal to 0. If it's less than that, if it's not greater than or equal to 0, then I end up getting a negative value. And you know what happens then. I get an imaginary number. And for our purposes here, we want to have real numbers. X minus 3 greater, so I have x is greater than or equal to 3. Simple as that. And then using the interval notation, I'm going to go from 3 to infinity. And that's it. I've got the domain of my second function. So I'm just going to use the interval notation to save space from 3 to infinity. Okay, the third one here, the domain of this one, I need my denominator to be positive. So I need negative x minus 1. I'm going to see when does that equal 0, and then I'm going to eliminate that value from the domain. So I get negative x, I add 1 to both sides, and then I divide by negative. So I get x is equal to negative 1 is the value that will make the denominator 0. So I want to eliminate that value from the domain. So I'm going to do this in interval notation. And the interval notation is that I can use all values from negative infinity up to negative 1. And then I can use all values from negative infinity, from negative 1 to infinity. And I have used parentheses here with my interval notation indicating that negative 1 is not included. I'm not allowed to use negative 1. On both sides, negative 1 is not included. But then everything else is included. And then whenever I have more than one part to my solution, I join that with this symbol, which is called a union. That's called a union symbol, which just means that I'm linking the two parts together, or both parts are included in the solution. Okay, moving on to the third one. Now, here you'll recognize that I have two things happening. One is I have a denominator, and the other is that I have a radicand. Let's kind of take both separately. So I take x plus 7, and that's got to be greater than or equal to 0. So x is greater than or equal to negative 7. So that's the first part. The other part is that I can't have x plus 7 equal to 0. So I set that equal to 0, and what do I get? When will it be 0? When x is negative 7. Now I need both of these conditions to be met. So I need to have x has to be greater than or equal to negative 7, and x cannot equal negative 7. So think about that. X has to be greater than or equal to negative 7, and x cannot equal 7. So can you put those two together and say what the domain is? I think you can. Putting those two together, we're going to say x has to be greater than negative 7. And that'll meet both conditions. It's both greater than or equal to negative 7, and it doesn't equal negative 7. So that's the domain there. I want to go back up to the fraction one here for a second. So, and I'll just finish this one here. X is greater than negative 7, and then I've got my interval notation, parentheses, because negative 7 is not included, and then up to infinity. All right, let's go back up to this. A common thing that you'll see with a fraction is we might have a couple of factors. So let's go x plus 2, x minus 3. So in this case, the domain is I cannot have a negative 2 because that would come out to 0, and I cannot have a 3 because that would come out to 0. So how do I write that with interval notation? I'm going to go from negative infinity up to negative 2, union, negative 2, up to 3, union, and then I'm going to go 3 to infinity. So that's kind of a pain, but that is how we would do that if we needed to represent that in interval notation. Now, pay attention. You might be asked what the domain is, or you could be asked what values are not in the domain. So you got to be careful what question you're being asked. So if I'm being asked what's the domain, this is how I would respond to it here. I'm afraid this looks like a bracket. I'm going to make sure that's clearly parentheses. And then the other question could be, well, what values are not in the domain? So what's not in domain? And in that case, no interval notation, and it doesn't take a lot to say. I just go -2, 3. And I say those two values are not in the domain of this function. And that is a review of domain.